Let's understand light, mirrors and lenses in this video. Have you ever read the warning that objects in a mirror are closer than they appear? Or noticed a curved line on reading glasses? Imagine Meena at a science center, looking into a row of curved mirrors. One mirror made her face look huge. Another turned her brother upside down. And a third gave a tiny version of herself. Why do mirrors behave so differently? First, a simple observation helps. A shiny spoon acts like two mirrors. If you look at the inner side of the spoon, the image can look upside down. If you look at the outer side, the image is upright but much smaller. Mirrors shaped like parts of a sphere are called spherical mirrors, and they explain these effects. A spherical mirror has a reflecting surface that is part of an imaginary hollow sphere. The surface can curve inwards or outwards, and each kind acts differently. A concave mirror curves inwards, like the inside of a spoon, and can make nearby images look big and upright. When an object moves away from a concave mirror, the image can become inverted and change size. A convex mirror curves outwards, like the back of a spoon, and always makes smaller upright images. Spherical mirrors are made by grinding glass into a curve and adding a thin reflective coating such as aluminium. If the coating is on the outer curved side, the mirror acts like a concave mirror. If the coating is on the inner curved side, the mirror behaves like a convex mirror. How can you tell mirror types by what you see? If a mirror gives an enlarged upright image when you are close and an inverted image when you move away, it is concave. If the image is always small and upright, it is convex. If the image is the same size and always upright, it is a plane mirror. Mirrors also show a side-to-side reversal called lateral inversion. So left and right appear swapped. Both kinds of spherical mirrors have many uses in real life. Concave mirrors concentrate light, so they are used in torches, car headlights, and searchlights. Dentists use small concave mirrors to get an enlarged view of teeth. Convex mirrors give a wider view, so they are used as side view mirrors on vehicles and at road bends and in shops. Telescopes often use large concave mirrors to collect light from distant stars. Now let us look at the two simple laws that explain reflection. First law: the angle at which a light ray hits a mirror equals the angle at which it bounces off. Call the incoming ray the incident ray, the outgoing ray the reflected ray, and draw a normal, which is a line at right angles to the surface at the point of contact. The angle between the incident ray and the normal is the angle of incidence, and it equals the angle of reflection. Second law: the incident ray, the normal, and the reflected ray all lie in the same plane, so they stay flat together. You can verify the first law in class using a torch, a narrow slit, paper, and a mirror, and you will find I equals R every time. These laws work for every point on a spherical mirror, so they explain why concave mirrors converge rays and convex mirrors make rays diverge. Be careful. A concave mirror can focus sunlight to a small bright spot that can burn paper. So never look at the sun or at focused sunlight. Now lenses. A lens is a clear piece of glass or plastic with curved surfaces that bend light as it passes through. A water drop on glass acts like a simple lens and can make letters look larger. A convex lens is thicker in the middle and brings parallel rays together, often making enlarged upright images when an object is close. A concave lens is thinner in the middle and makes rays spread out, so images are always smaller and upright. Convex lenses can also focus sunlight to burn paper, like a burning glass. Lenses are used in eyeglasses, cameras, microscopes, telescopes, and the human eye, which has a natural convex lens. So, what do we learn from this? We learn that mirrors and lenses change how we see things by reflecting or bending light. and simple rules let us predict the images we get. Let us quickly remember. Concave mirrors can enlarge or invert images depending on distance. Convex mirrors always give small upright images, and plane mirrors give same size upright images. The laws of reflection are I equals R, and the rays lie in the same plane. And convex lenses converge while concave lenses diverge. So today we learned how mirrors and lenses form images, some simple tests and important uses. Keep exploring with small experiments like a spoon, a drop of water, or a torch and a mirror, safely and with care. Happy learning! And do check more easy explanations and activities on EduRev when you want to learn further.